Hello everyone and welcome back to the channel. Imagine you have a cluster of identical servers all trying to work together on a task. Who should perform the critical write operation? Who should send that one notification email? Without coordination, you would have a chaos, duplicate actions, data corruptions, and a broken system. This is the fundamental challenge solved by leader election. In system design interviews, discussing leader elections shows a deep understanding of how to manage state, orchestrate resources, and ensure consistency in complex distributed systems. Today, we are diving into its core concepts and key algorithms. Okay, so let's try first to understand what is the problem that leader election solves. In distributed systems, where you have multiple nodes working together, you often need you often need to designate a single authoritative entity to perform a specific task. Why? Why we need that? First, to avoid conflicts. Like without a leader, multiple nodes might try to perform the same unique task simultaneously, leading to duplicate transactions, like for example, double payment processing, sending two welcome emails in the same time, things like that, or even conflicting decisions. Number two, centralized coordination. While you want to avoid a single point of failure, which is SPOF, some tasks inherently required centralized coordination. Leader redirection provides a way to have a single coordinator while still maintaining high availability. Lastly, I would say it's resource management. A leader can manage shared resources, assign tasks to workers, or ensure that only one node handles writes to a particular data partition. This problem becomes critical when nodes can fail. Network connections can be flaky, and you still need your system to agree on who is in charge to ensure progress. Okay, so what is exactly leader election? Leader election, it's a process by which node in distributed system collectively designate a single primary node as a leader to coordinate tasks, handle specific operations like all writes, or manage shared resources within the cluster. The goal of this operation is to ensure that any given time there is exactly one leader among a set of active healthy nodes. If the current leader fails, a new leader must be elected quickly and reliably. Think of a team of equal peers working on a project. Instead of everyone doing everything, they collaboratively elect a temporary team leader for a specific phase. And if that leader steps down or gets sick, they elect a new one. Okay, so there are some properties of a good leader election algorithm. We will discuss four of them in this video. First, we have safety. At any given point in time, there is at most one leader. This is paramount to avoid the dreaded, which is like split brain problem, where two or more nodes incorrectly believe that they are the leader, leading to data corruption or conflicting actions. Number two, liveness. All active nodes eventually agree on a leader, and if the current leader fails, a new leader will eventually be elected. The system makes progress. Okay. Number three, fault tolerance. The election process must success even if a minority of nodes in the cluster fails. For example, for 5-node cluster, it should work if one or two nodes fails. Number four, which is last, efficiency. The election process should be fast and consume minimal network and CPU resources. Okay. So next we will talk about some leader election algorithms. We will talk about Raft, we will talk about Apache ZooKeeper, and we will talk about the bully algorithm. We started with Rafts because it's the most interview relevant one. So the concept of this one, Raft simplifies consensus for understandability. Nodes exists in 3 states. As you can see, we have follower, candidate, and leader. Every follower has an election timeout. If a follower doesn't receive a heartbeat from the current leader within that timeout, it assumes the leader has failed and transition to a candidate state. The candidate will increment its term, okay? Votes for itself and request votes from other nodes. If a candidate receives votes from the majority of the nodes, it becomes the new leader. The new leader then starts sending heartbeats to all followers. If 2 candidates split votes, they will eventually time out and re-elect, potentially with a randomized delay to avoid another split again. So this used in I guess in CockroachDB, and also I guess it's used in HashiCorp console. I guess I'm not that sure, but I guess. Okay, so next we will talk about the Apache ZooKeeper. Apache ZooKeeper is distributed coordination service. It doesn't implement leader election directly as an API, but it provides primitives that allow clients to easily implement leader election. How does it work? Multiple clients might try to create a special inferior node. Inferior nodes mean that a node that disappears when the client disconnects, okay? Under a specific path. The first one to successfully create it becomes the leader. That's it. It's pretty simple. Other clients will watch that one node. If the leader disconnects and its inferior node disappears, the watchers are notified, which is the clients here, and they can then compete to create the new node and initiating a new election. And this is used in many distributed systems like Kafka and HBase and yeah, things like that. Lastly, we have bully algorithms. It's simpler but less robust. The concept of this one, when a node detects the leader's failure, it sends an election message to all nodes with a higher ID. If no higher ID nodes responds within a timeout, the current node declares itself the new leader. If a higher ID node responds, the node takes over the election, and that's it. It's pretty simple. The concept of this one, I guess it can be chatty, like many messages, and always selects the highest ID, which might not be optimal for workload balancing. Okay, why leader elections matter? I would say in distributed systems, first we have distributed consensus. It's often the first step in achieving strong consistency and agreement on distributed systems. Number 2, I would say resource coordination. Assigning unique tasks, distributing work among work nodes, preventing duplicate operations. I would say also high availability because it ensures that the critical centralized functions always have an active coordinator, even if nodes fail without introducing a single point of failure. Lastly, it will be something about focusing about the interview, like interview focus thing, which be, I would say, discussing leader election demonstrates a deep understanding of fault tolerance, coordination, and consistency in distributed systems. So, if you have a question in your head, how you will discuss leader election in system design interview? I would say in system design interview, you could bring up leader election whenever a component requires a single coordinator for rights, task management, or shared state management in a multi-node cluster. Discuss how you would detect leader failure and the importance of quorum to avoid the split brain. Raft is often a good example to reference due to its clarity. So yeah, that's it for this video, and see you in the future.